attention so I don't lose you. So we have a farmer has 400 yards of fencing. That's the perimeter. Yeah. It's what you use to fence around the outside, correct? So we know that the perimeter equals 400 yards. No. And wishes to find 3 sides of a rectangular field. So wishes to find, that's not true. I just read it. That's what it's losing. Wishes to fence 3 sides of a rectangular field. The 4th side is an existing stone wall and needs no fencing. So what is the actual perimeter? The actual perimeter is 400 yards. What's the perimeter equation? P equals
L times W.
2L plus W. 2L plus 2. Because only one W because one of the sides are the full perimeter.
Okay, let's discuss how we would get a maximum area. Ready? If I have an existing wall and I'm allowed 2 lengths and a width or 2 widths and a length, because that's all I'm really allowed, right? This is the wall. Look at that wall. If I do fencing and I do 2 widths, it's supposed to be a different color. Thanks. 4. Really working it out today. All right. So if this is a width and this is a width, and then the length is across the wall, width, length. Would that make a bigger area? Or would you have a length and a length? Well, now the length would have to be this would. Oh, she does. You'd have to have that be the width. This would be the length, let's say, and this would be the width. Which one's going to end up with it? Properly, the one you're going to try and make the wall be the length, because then the wall is the largest area that you don't have to fence, right? You want to make the part that is fenced, that you don't have to put fence, as a length, okay? Now, say you mess up. You're going to get an answer. Your width is going to be larger than your length, and then you're going to second guess life. It's just because you have the letters the wrong way around, okay? So say you mess it up and you put 2 lengths and 1 width. You'll just find out the width is smaller or larger, which doesn't make sense. All right, so let's go back here. We're going to have 2 widths plus a length. And so now we have a formula which is 400 equals 2 widths plus a length. And that's always step 1 with these farmer questions, is to get your perimeter equation.
Will there be any questions where, like, it gives you which side, like, the existing wall is?
No.
Or you always just get...
And like I said, if you pick wrong, you'll find out that the answer will be backwards. Your length will be smaller than your width, and you just have to change your letters. And you're going to do let statements. So say you use X and Y, or say you use W and L. The way to fix the question is you'll say, like, let L represent length, let W represent width. If they're backwards, you'd be like, let L represent width, let W represent length, which would be stupid, but it would fix the question immediately, right? And you wouldn't have to redo it. Okay, so we do have to give let statements because we gave variables. So let P represent perimeter. We can't just assume that people know what our letters stand for. Let L represent.
Are we allowed to write this as red?
Yep. You actually are.
Right.
And let
I know the people on the podcast.
W rep. You're allowed to use rep because that's what it stands for. Rep width.
Oh, that's people are like going crazy right now.
Okay, so let's go back up to the question. The 4-side existing wall and needs no additional fencing. Find the dimensions of the rectangular field of largest area. So we talked about largest area, so max area. If we're trying to find the maximum, we're trying to find, if we're trying to find area, length times width, right? We got that. If we're trying to find max area, we're trying to find the critical numbers of the first derivative. That's the difference. First derivative of area, okay? So the first thing we're going to need, I'm going to go let A represent area, or you could just write out the word area when you do the equation, and it would work, okay? So we have area, this is step 2, area equals length times width. Do you guys remember what we had to do?
Isolate one of W or L in column.
Yeah. So I'm going to isolate L because it's easier. So I get negative 2W plus 400. And it's going to go in for L. Negative 2W plus 400 times W. Then I have to distribute. Now, if you don't distribute, you're going to be doing product rule with polynomials, which would take way longer. So I'm going to distribute. And I'm going to get area equals negative 2W squared plus 400W. Now, this is area, correct? Now, to get the maximum area in grade 11, like I said, we would complete the square here, and poof, we have our area. In calculus, though, if we want a maximum, we have to find the what? First derivative. So if I got area, cool. If I want max area, I have to find the first derivative. So I write max A.
Maximum A.
Or I can just go A prime. And I get negative 4W plus 400. And then to get where that's going to be at, what do I have to do?
W.
Find the critical number, set A prime equal to 0. Subtract 400. Get negative 400 equals negative 4W. Divide by negative 4. W equals 100. How do I get L? 100 yards. How do I get L?
Plug it back in.
Plug it back into the original, or the L equals 1, which is what I would do. So L equals negative 2 times 100 plus 400. So it equals 200 yards. So they often ask one of two questions. The dimensions, guten Tag, the dimensions that produce the largest area are 100 yards by 200 yards. Now, to prove that it's a maximum, how could we prove that this value 100 would create a maximum? We should make a number line. What's the faster way? Second derivative. So what would the second derivative be? A double prime equals negative 4. So no matter what, this is producing a negative second derivative, no matter what critical number I put in. A negative second derivative does what?
Maximum.
Maximum. So if they asked you why is it a maximum, you'd say, well, using the second derivative test, it's always going to be negative, therefore there's always going to be a maximum no matter what critical number I put. If they ask you. This one just asks for the dimensions. I was talking on it.
Yeah.
Okay?
I would have proved that like specifically this is the maximum, or is there could be like a second maximum or not?
It's a quadratic, so it can only have one. Okay. I want you guys to look at this one. It says a metal box without a top is constructed from a square sheet of paper. Now remember, it's a square sheet of paper, this one. And it doesn't have a top on it. So remember we had like our fold line, which is not really working well for me here. Right? And those corners don't exist, correct? So here it says a metal box without a top is to be constructed from a square sheet of metal that is 20 centimeters on a side by cutting square pieces of the same size from the corners of the sheet, which we call X. Remember that? And then folding up the sides. Find the dimensions of the box with the largest volume that can be constructed in this manner. So, I'm going to pick a different color. So this here would be an X. This would be an X. These are all X's, right? And what's the side length on both of these? 20. So this whole length across is 20. So we know that our width would equal what? What would the width of this box be? 20 minus 2x. And the length?
20 minus 2x.
And the height?
X.
And the largest volume is what we're finding here. So volume first is what formula? Length times width times height. So what's this one going to be?
20 minus 2x squared times x.
So I would normally write 20 minus 2x squared. I absolutely agree with your statement. However, we're going to have to find the max volume, so we're going to have to find what?
Numbers.
The first derivative to get the critical number, setting it equal to 0. And if I put those together as a squared, we're going to have to expand these out, right? And the moment that people write them out with a squared, remember they only do the first term and the back term, and they never get that middle term. So I will tell you to cross the squared off and write them out twice, so you don't mess that up. So before we go to find the actual first derivative of this, you're going to have to FOIL that out and then distribute the x and then do the derivative. So try it out, see if you can get the dimensions that result in the largest volume. How would I get the max area of this one? If they wanted the max area, what would I just have to do?
Take 200 times 100.
200 times 100, right? 200, nope, I'm going to have 20,000 yards squared, right? Okay, try this. Okay, when we expand this, we're going to get 400x minus 80x squared, not sure I'm writing this backwards, plus 4x cubed. Okay, now, if we want the max volume, we're going to do v prime, which would be 12x squared minus 160x plus 400. What can I take out? A 4. And so I'm left with 3x squared minus 40x plus 100. What does that get me? 300. What multiplies to me 300 adds to me
No,
negative?
no, no, no.
Negative 30 and
Negative 30 and negative 10?
it actually goes from circle myself.
So v prime equals 4.
She wrote these questions.
This is why Catherine's my favorite right now. Okay, so we're going to group. We're going to put a plus sign in between. And we're going to get 4 bracket 3x, x minus 10, minus 10, x minus 10. And then we get 4, 3x minus 10, x minus 10. And we're going to get two x values because we have set this equal to 0. X equals 10 over 3 and x equals 10. Well, what did it ask us? It asked us, and that's just the height, right? We have to fill it in to get our actual length and width, which are the same as the square. It asked us to find the dimensions of the box with the largest volume. So I'm looking for max volume, correct? One of them will get me it, and one of them will not.
So if you take 20 minus 20.
Yeah, it also just goes away, but by the by. If we do v double prime of x, we're going to get 24x minus 160. And if we do v double prime of 10 over 3, which is the one that when you fill it back in doesn't give you 0 for a width and a height, you're going to get 24 times 10 over 3 minus 160.
I don't see a Lepp V rep volume.
Pardon?
I don't see a V Lepp.
I don't have to. I have volume.
Oh, I wrote volume.
And then V prime, how do you know V prime equals volume prime?
You write your last statement.
Oh, is it?
I would literally just write volume.
I didn't see the left.
On a test, I would write volume. Okay, so then here we have 240 over 3, which is 80, minus 160, which is negative 80, which is negative, which means this is a maximum, correct? Second derivative test shows that. So we have a maximum at 10 over 3. If that doesn't a giveaway, filling in 10, 20 minus 2 times 10 gets me 0 width, 0 length, and then 10 height. If it is 0 width and 0 length, it can't be a box. It doesn't actually, it's just, there's just like a pen, I don't even know. Something, you can't have width or length, so it's actually nothing. It's just like a floating pen.
If they both worked, would you just like do the same for both of them?
Yeah, both of them will win. One you just tie boxes that make it 0. Yeah, because it's usually next intercept. All right. So, our width and length equals length equals 20 minus 2 times 10 over 3. So we're going to get 20 over 3 over here, and then we're going to get 60 over 3 over here, which equals 40 over 3 yards. No, I don't even know what this is. Centimeters. I went back to the previous one. Okay. So 40 over 3 is one of them. Height equals 10 over 3 centimeters. So then you have to have a statement that says the dimensions of the field. Nope, that's the third question. The dimensions of the box. That's the next question. The dimensions of the box with the largest volume are 10 over 3 centimeters by 40 over 3 centimeters by 40 over 3. Okay, then we're going to go to the third one, which is a farmer question or a field question, I guess. I call it a farmer question whenever it's a field and they do something. But there's cost involved. Because each certain area of the fence costs different amounts of money. So we're going to have to use a cost equation. So here we have a rectangular field adjacent to a river is being enclosed, fencing along the river. They're actually fencing the river in. It costs $5 per meter, and the fencing on the other sides costs $3 per meter. The area of the field is 1,200 square meters. Don't know what I'm reading. Find the dimensions of the field that is least expensive. So least expensive is what we want. Now this is the catch. What costs a different price? The river side, but it's going to be the same length as the one across from the river side, correct? Because you're making a rectangular. So I'm going to say let X represent the length of fence along the river. Let Y represent the length of fence perpendicular to the river. we want to come up with a cost equation. So I'm going to say cost. I don't want anyone telling me I didn't write a let statement. So, cost. What costs what? $5 for every piece of fence along the river, right? So we're going to have 5x. This is true. So we have 5x plus, now we need $3 times every length that is not out along the river. So what are we going to multiply it by? Not y. We need to multiply it by all the lengths that are not along the river.
Well, there's only two that are perpendicular, there's one that's parallel.
Yeah, so what do you say?
Two. Only two perpendicular.
No, we still need to fence in everything.
2y plus.
2y plus x. Because the other three sides are fenced in at $3. So, if we look at it this way, here be the river. This piece of fencing costs $5, correct? Sure. And this side length is an x, okay? Then these three sides here cost $3. And what would they be represented by? A y, and a x. Hence, 2y plus x. Oh my goodness. Okay.
So x represents the length of fence along the river and parallel to the river.
Yes. Essentially, because they have to be the same length, because it said it's rectangular. Yeah. Okay, so we get 5x plus 6y plus 3x, which actually results in 8x plus 6y. We are not doing implicit differentiation. We need to get something to go away. How can we go about that?
You derive.
From the area of the field.
The area of the field is what? So we have area equals xy, and what is the area? 200 with a 1 in front. Yep. Xy.
1,000 meters squared.
Cool. Okay, so are we going to isolate the x or isolate the y?
Why?
I do the same every single time. So I'm going to divide by x.
Everybody agrees.
I would have picked y. So y equals 1200x. 1200 over x, sorry. And where's that going to go? Sub it in for the y. Because, guys, we are trying to minimize cost, correct? People are like, I don't know which one I need to derive. I don't know if I need to derive the area one or the cost one. Well, we're trying to find the dimensions that are the least expensive, so minimize cost, correct? So we're going to minimize the cost equation, which means we're going to find the first derivative of the cost equation, not the area equation. Okay? So we're going to get cost equals 8x plus 6 times 1200 over x, which is just fantastic. So we get 8x plus 7200 x to the negative 1. Why would I do that? It's easier to drive that way. Yeah. So you guys try and figure out the rest. Derive it, see if you can get. Okay, quiet please. So we have cost prime equals 8 minus 7200 x to the negative 2. So we move the 8 over. We get 8 equals negative 7200 x to the negative 2. Then we are going to divide by negative 7200. There's another way, but I'm doing it this way. I don't really care. Is it 1 over 30? What is it? Oh, 90. Yep, it's 90. 1 over 900. It needs to square root to 30. Okay. X to the negative 2. Now, x to the negative 2 is the same as 1 over x squared. I could bring it up and bring the 900 up, swap them. I could do that. Or, remember, I want it to the power of 1, so I left it like this to prove a point. So 1 to the power of 1, I can raise to the power of negative 1/2. Come on. Negative
So many.
1/2. And that flips to 900 to the half, which is the square root of 900. Square root of 900 gets a plus or a minus sign. What's the catch though?
Negative 30 is dumb.
Negative 30 is done. So we get 30 something. I don't remember what this one is.
Meters.
Meters. Coo. And then we get x equals negative 30 meters, which circle, line, street. This is the right response on the AP exam. You'd say negative 30 meters. You wouldn't use the word extraneous. You can just say negative 30 meters. Does not work because that is a length of negativity, which we cannot have negative lengths.
Why can we not just write down extraneous?
Because you want to explain it. When you see the written response, you'll see you need to explain yourself. Because it's like explanation, 1 mark. Blah, 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 1 mark. Nothing
How
else.
much space do
1
they
mark.
give us?
They give a normal human space. So John's going to have to take it down like to font 200 to font
30.
maybe like 20. I'll give you font 18.
We'll just write over to that, just like.
You have to write within the boxes, so they put a box on it, the paper. You have to write within the box. If you write outside of the box, they won't look at it because they scan it and send it to people, I think, tomorrow. Would be my guess. I don't really know. There's not a lack of space. Trust me. And what they'll do too is if it's in a non-calculator section, they'll let you leave it as like just determining the derivative of this. They'll leave it as the derivative of f of x is how you would find it, and this is how you do it, blah, blah, blah. And they don't even make you find the derivative, which is fantastic. If it's in the non-calculator section, because it could be a really hard one, right? So they let you just leave it like that, which is actually quite nice. All right. The question is, the area of the field is to be told to find the dimensions of the field that is least expensive. So what are the dimensions? How do I find them? 30, and then this one I go y equals 1200 divided by 30, which is what? What's 120 divided by 30? 40 meters. The dimensions of the field that are least expensive are 30 meters by 40 meters. So this one is a rectangular playing field, has an area of 600 meters squared. That's beside the point. You guys can deal with that after. Find its fencing to enclose the field and divide it into 2 equal parts. So remember, when you have fencing and you want to divide it into 2 equal parts, what people will often say is it's a width, length. That's not how it goes. You'll make these sides over here both be lengths and these be widths. Whether that matters or changes anything, I don't know. I want you guys to try the question. Write your own let's statement. From your textbook, the solution to this last question is in Google Classroom. This is from your textbook.